All right, welcome everyone. Just give us another minute or so to let people join into the webinar. There are quite a few people in the waiting area, so just give us another minute and we'll go ahead and get started. But I want to thank each of you for being with us. I know we have an audience that is covering all over the world, so good morning, good afternoon, good evening, and some of you late in the evening. So again, thank you very much for being part of it. And again, I want to thank also some of you who were at our IWCS Cable and Connectivity Industry Forum in Providence a few weeks ago. That was very well attended with a lot of great information, including several papers on AI, which was very interesting and creating a path forward, and we'll want to enhance that in future conferences. So again, let's just wait another few seconds. Okay, why don't we go ahead and get started? And again, my name is Dave Cadu, and I'm honored to be the CEO of IWCS, and I'll be your moderator for today's webinar event. And a few housekeeping items for you. Please note, as an attendee, you're part of a larger audience. So during the presentation, all participants will remain in listen-only mode, but also be reminded that the event is being recorded for rebroadcast. IWCS does not share the PowerPoint slides, but you can reach out to our friends at Odin Technologies, and we'll provide you some email links if you wish to contact them directly. We encourage you to submit written questions during the presentation at any time using the chat function on the right of your screen. After typing in your questions in the space at the bottom, please hit the send button and your questions will be addressed, time permitting, at the end of the presentation. Today, we're honored to welcome Ahmad Achia, who is a customer experience lead and staff solutions architect for Odin Technologies out of New York, USA. Ahmad will be presenting his perspectives on the use of artificial intelligence to give junior operators the performance of experienced staff. And I'll tell you, we really do need that as we try to bring young professionals into our industry. So very happy to be talking about this for the future. Ahmad Achia is again, staff solutions architect at Odin Technologies, a company that uses advanced AI and data to enable inexperienced operators to perform like they have been managing their lines for 30 plus years. Ahmad is an expert in identifying and deploying high value case studies that align with the business objectives and working closely with customers to make their goals a reality. Before joining Odin, Ahmad worked as a technical consultant on digital transformations across a multitude of industries. So we welcome Ahmad to present at today's IWCS webinar event. And again, thank you. Take it away, Ahmad.
Excellent. Thank you for hosting me, and thank you everyone who's joined remotely. I'm very excited to be giving this talk today about how we use AI to give junior operators the performance of experienced staff. So we're really going to be talking about how we can improve operator performance, allow them to ramp up faster, and address a labor challenge that really has been a dominant problem in the manufacturing industry, including wire and cable. So we know that there's a lot of domain knowledge that's kept by the most experienced operators. We hear time and time again that their process is more of an art than a science. And what we're doing at Odin, what we'll be talking about today in more detail, is how we use AI to make it easier to become artists. So today we'll cover background on AI and machine learning. We'll touch on the challenges in manufacturing and Odin's approach. We'll talk about some of the business opportunity and Odin solutions, and then we'll finish off with some case studies. So again, I'm a staff solutions architect at Odin. Thank you for the introduction, David, but Odin is a data and AI company focused on manufacturing. We are really focused on the front line and providing useful information to operators for them to have good performance. We work on democratizing the access to data, transferring domain knowledge, and distributing it evenly within manufacturing operations. One of our biggest focuses is delivering fast time to value. We know manufacturers don't have time for tools that aren't immediately showing value, and we're continuously innovating to ensure that we're providing better solutions for our customers. The Odin product suite is made up of three main components. Today, we'll focus mostly on the one in the top right, Process AI. That is our AI recommendation engine that provides predictions and is targeted at operators. But without the power of the data engine, Process AI couldn't be possible. And the data engine allows us to take data from MES, SCADA, DCS systems, ERPs, to get a full picture of the process. We also have factory analytics paired in tandem with Process AI. That allows us to understand the impact and utilization of tools, as well as perform other types of root cause analyses and monitoring use cases. Quick look at Odin's customers. So we're taking a focus on wire and cable here. But one thing you'll notice about all of our customers is that they are operator dependent. They feel the limitations of having a lot of tribal knowledge. They all share the more of an art versus science mentality. And we find it critical to support these operators with the best tools possible to have a good day on the manufacturing floor. So before we dive deeper into the labor challenge, I wanted to give a primer on AI. So first, let's start by defining what we mean by AI and how it's sort of structured in layers here. So AI is the broad concept of machines simulating human intelligence, making decisions, learning from data, and adapting over time. Within that, we have machine learning, where machines learn from experience without needing to be explicitly programmed for each task. And that allows them to improve automatically as they gather more data. Digging a layer deeper, we look at deep learning, which is a subset of machine learning focused on finding patterns in complex data. It attempts to simulate how our brains analyze and understand information, and it's particularly valuable in manufacturing where there's endless data points and variables at play. At the core of that are artificial neural networks. These are structured in layers to recognize complex patterns, kind of similar to how experienced operators use years of intuition and knowledge to make quick and informed decisions. So in our case, by leveraging these AI approaches, we can essentially provide junior operators with tools that allow them to act on data with the insight of experienced staff. It doesn't just simulate the experience, it amplifies it and helps make operators better, faster decisions on real-time data and years of historical insights. So before we move on, I wanted to jump into a survey, a poll. Give me 1 second. Sorry, do we have the moderator with the poll, or should I be pulling that up?
Yes, the poll is posted in the chat. If everyone could look to the chat, and we have our first poll question.
Great, I'm seeing those first replies coming in. Thank you for taking the time to respond and for posting that question. I see as the answers are coming in that there's a mixed bag of responses. We have, so the question was, is your company investing in AI within the next 6 months? Seeing that the majority of people are answering no or not sure, but a good chunk are also familiar with AI investments taking place within or outside of their department. So that's great to hear. Hopefully we can help you understand a little bit more about how AI can apply to your business. Thank you all for your responses. So let's look at some common use cases for AI, you're likely to have come across at least one of these by this point. So starting off with image generation, these are generative models, usually multimodal, which means that they can interact with images and texts. We have training and recommendation engines, which provide recommendations and optimize information for the purposes of training. We have anomaly detection, which is kind of more akin to your classic machine learning regressions, things like predicting outcomes like quality or predicted maintenance. And then finally, we have content generation, like large language models. Another generative approach that's obviously been very prevalent in the last couple of years here. So let's take a look at large language models. To start, many people today equate AI with large language models just because they've been driving a lot of the investment and excitement around AI, but just wanted to level set on use cases here. So just to get a foundational understanding for how LLMs work, despite them being enormously complex systems requiring lots of training and fine tuning and compute power, the way they work is fundamentally easy to understand. At a rudimentary level, words are converted into tokens. They're fed into a series of neural networks called transformers. That's what the T stands for in GPT. And their sole responsibility is predicting the very next word. So that output, as you can see on the right here, is a probability distribution of the most likely next word. And that output is then refed into the model and the next word is regenerated. That's, if you've used ChatGPT, that's why it can appear to be thinking about the next words as they come out sequentially. But this kind of fundamental notion of understanding context and predicting patterns is incredibly powerful for our purposes. LLMs in particular can assist operators with the most relevant information or next steps based on work instructions and current process conditions, almost like a experienced operator right by their side. And this is a current focus area for Odin's product R&D. So we mentioned process AI at the top. We'll take a look at that a little bit later, but wanted to first dive into another one of Odin's applications, which is predictive quality. A common limitation that operators are faced with is the lack of visibility into quality outcomes in real time. They often have to take a sample off the line, wait anywhere from 30 minutes to several hours to see how those process changes are reflecting in those quality results. And what that ultimately results in is operators being hesitant to make adjustments. The cost of failure is, understandably not worth the risk of operating more efficiently. That's either faster with less material or less energy consumption. But at Odin, we develop predictive models to give operators that real-time feedback about how adjustments that they're making will impact the final outcome. So using this in tandem with process AI recommendations, operators can be confident that the changes they're making won't cause quality failures, and they can continue to push the envelope of the process. So our approach is focused on quickly delivering models that are as accurate as possible, and then working with our customers to fine tune them. You can see in the bottom left some of the targets that we're going for. We call these service level objectives, or SLOs. We're generally looking for greater than 70% correlation, greater than 90% accuracy, and we want our P95 error to be within 3 standard deviations. Odin uses a machine learning stack to enable our team to quickly take in customer feedback and iterate models and essentially deliver models in a turnkey manner. Let's take a look at a specific example that we've deployed for a wire and rod customer that's actually exceeding our SLOs. So this model looked at nearly 150 process variables, selected the top 60 contributors as inputs to the model. And of those 60, only 14 were really key to understanding the process, meaning their weights heavily outweighed the others, and the bulk of the outcome is being predicted by these 14 variables. One thing that we always find when we're rolling out predictive quality is that customers are surprised that only a handful of metrics account for the bulk of the model features, and there's often a lot of good conversation and back and forth about these top contributors that are picked out from data sets. Usually most of these make sense and track with the existing process understanding, but there's usually at least a few that are surprising and provide new insights into the process. So we use a collaborative approach to achieve success. Offline or predictive quality is turnkey where it matters, but we take that consultative approach to ensure the models are fine-tuned, that we're correctly capturing the nuances of the process. So let's talk a little bit about manufacturing data. Across the board, one of the biggest challenges for delivering AI and machine learning solutions is the quality of the input data. This is potentially even more pressing in manufacturing, where you have machines of different ages, OEMs, reporting real-time conditions. So across the board, data is messy, overwhelming, and accurate. And if you start to build models and solutions on that foundation, you'll have trouble generating accurate results and meaningful recommendations. So when we say messy, we know that tags can exist in many different systems. They may not be named appropriately, may not be tagged with the right units. So ultimately are missing context. Data can also be overwhelming. There's a tremendous amount of data that's being generated on a factory floor, millions of data points a day usually. In fact, for one of our customers, we're processing over 1.5 billion events a day. And inaccuracy is an interesting one. We'll touch on an example of that a little bit later. But of course, if data is inaccurate, then the outcomes, the predicted models will also be inaccurate. So we use kind of machine learning upstream in our data ingestion to ensure that the final data set is accurate and usable. So you don't have to just take my word for it. The Manufacturing Leadership Council, which is sponsored by several leaders in the manufacturing data space, say that 65% of manufacturers see data issues as a blocker to adopting AI, and that definitely tracks with what we see with our customers and prospects. So how do we prepare data for AI? Out of that messy picture we just talked about, we need to ingest the data, clean it, enrich it, which adds context and improvement before we can really train models and predict things and make recommendations. So we talked about this product suite. We have a purpose-built data engine to ingest and contextualize millions of data points in real time through our integrations to existing systems. That same data engine that powers Process AI and Factory Analytics is used by our own data scientists for model training and development, which allows for a clean, contextualized, and easily queryable and aggregated data set. So we'll take a deeper look at data enriching here and jump into an example. So here's an example of how we automatically clean, contextualize, and infer data from the process. This is an example of a manufacturer going through a changeover. So let's take a closer look here. We can see that the line speed, which is in green, we'll see that goes to 0 and then remains 0 for a while and then goes up here. On top of that, we are generating a contextualized downtime interval. We are also, interestingly, capturing information from the MES. So this purple bar here is where the MES believes the changeover to have occurred. Now, at a glance, we can tell that this is, is somewhat accurate, but not the full picture whatsoever. This changeover actually only persists until this vertical black bar here, which indicates the change of a product. So it's really measuring when the line went down to when it was reported that the product changed. And on top of that, we're using machine learning models to generate these orange intervals here that give us the start time and end time to really understand the truth behind the changeover, which is that it actually started here when the line speed went to 0. It lasted well beyond the indicated product change, and actually a little bit beyond that as we were ramping up. So not only are we generating corrected changeovers, we're also understanding when we were ramping up, and that allows us on aggregate to say how long our changeovers are looking, benchmark them, and improve performance. This is anonymized information here, but under here we could actually see even what product types we're changing from. And this really allows us to reduce the non-value add activities that operators have to do. So rather than having to be overly concerned with inputting accurate data, they just tell the system what happened. And on our end, we are increasing data accuracy. Before we jump into some of the market conditions and challenges, I wanted to do another survey here. So I'll pause for that to be entered in the chat. And if you all would provide your feedback, that would be great. So the question is, where do you see the biggest opportunity for AI for the front line? We'll give folks a couple moments here to respond. Our options are training, manual operation steps, data entry, improving productivity and efficiency, maintenance, changeovers, or something else. And I'm seeing the results trickle in. It looks like the majority of the group thinks that improving productivity and efficiency is one of the top applications of AI in manufacturing frontline. And we tend to agree. That's exactly where we're focused. I would say the training is a secondary, another major focus of ours. You can't really improve productivity and efficiency without addressing the challenges of the labor market. So that is certainly a focus as well, as ensuring that we can help those new operators perform like seasoned veterans. So thank you all for your responses. We will keep moving along here and look at the AI opportunity for labor. So here's a graph from Fred. This can be a little bit painful to see, but is really interesting and kind of sums up the current conditions well. We've heard from our customers that these aggregated statistics mimic what they see, and we can see here that from around 1990 to mid-2000s, we had a steady increase in manufacturing productivity, that is output per hour for all workers, and have since 2010 plateaued. And we, digging in and kind of listening to our customer base and the market research, one of the key reasons is due to the decreasing tenure of operators. On top of that, there's also decreasing batch sizes of what's being made, increased complexity of supply chains, products, processes, and input materials. And overall, it's no secret that manufacturing operations are incredibly complex, and that all the efforts since 2010 with new tools and methodologies have only managed to keep us flat. So taking a bit of a closer look at the tenure problem from LNS, which is an analyst company focused on manufacturing operations, we see these fairly unbelievable stats. So this is comparing pre and post-COVID manufacturing tenure. We see that in 2019, the average tenure was 20 years, and that is down to 3 months last year. We also see the average time going from 7 years to 9 months, and the 3-month retention rate going from 90% to 50%. So these are huge changes and kind of underline the crux of the challenges that manufacturers are facing. And this is one of the core problems that we're trying to address here at Odin, that we believe AI can hold the keys to. Before we keep moving, pause here for another survey. So please direct your attention to the chat, and we will have another survey posted there shortly. So if you could let us know what the average tenure of your operators currently is, we will be interested to hear that and see if that really reflects what we're seeing here from the research. Give folks a few seconds to reply. definitely starting to see the replies trickle in towards the shorter buckets. Glad to hear not too many respondents think their average is in the 0 to 2 range, but it seems like majority of our responses are within the 2 to 10 year range, which definitely tracks with the research here. We're coming out of previous days where your average operator may have had 30 years of experience and built up a wealth of knowledge that really just lives in their brains, and they can kind of operate the machine like expertly, like an instrument. Great. So thank you all for the responses. We'll keep moving on here. So the operator challenges that are faced by manufacturers are intense. It's an incredibly challenging role. Here at Odin, we work with a large number of operators, and we all have an enormous amount of respect for their job, and it's incredibly challenging. There's often being met with many sources of real-time variability. There's, as we discussed, millions of disjointed data points per line, and how do you make, how do you get signal out of that noise? Staff is not always experienced with the changing constraints of the manufacturing environment, and oftentimes product recipes are changing, raw materials are changing, and that requires operators to be nimble and adaptive. Taking a look at some of the variability, this is an example from Odin, which is looking at one line and one product. So this is within a single spec. We see a scatter plot here, and each dot in this scatter plot represents a set of settings that can be used to make a product. And as you can see, there's a tremendous amount of variability here. And this is generally driven by operators. So we have along the x-axis here, your line speed, and along the y-axis, cost. So two very important measures for measuring efficiency. And we can see that kind of that broad spread, there's a lot of opportunity for not only increasing output and decreasing cost by moving that towards the bottom right. We call that the efficiency frontier, but also just by narrowing that spread and ensuring that that variability is kept to a minimum. So you can imagine just narrowing this towards the bottom right results in operators running faster at a lower cost and being able to hit those goals more frequently. So again, this is one line and one product having this much variability, and I will say this is not uncommon. Usually when we're working with customers and get to this point, the reactions to the variability are always intriguing. You can see kind of the light bulbs start to go off, where having it laid out this way really demonstrates how you could start pushing yourself towards more optimal operations. And that variability is largely driven by operators. So the gap is huge between operators. It takes a new operator several years to be onboarded. Even 2 years in, they might be experienced by most measures, but hard to call them experts because of all of the intricacies that go into running a machine, understanding the process, and all the different conditions that could come up during operations. So how do we turn these billions of data points into operator enablement? Using AI. So AI is really good at quickly cleaning and analyzing large data sets, but we're always reliant on our people to provide qualitative feedback, do the critical thinking and operating that is required. So people are always looking for new and novel ways of approaching a problem. We have great data that can be analyzed to make it easier for operators so they can focus on things when they're hard, addressing anomalies when they pop up, looking at machines that need special attention, and taking a focus on safety. So really combing through the noise and surfacing the right information using AI allows them to do their job better, more safely, and with more productivity. So we talked about predictive quality and how that helps us understand the output based on what's happening on the line. But through our product research and getting this in front of users, we really learned that one of the more pressing problems to solve is, if I want this output, what should my inputs be? So we started addressing the problem from both directions, and rather than just surfacing predictions, we are now building prescriptive and real-time recommendations. So we're sourcing and organizing billions of data points. We're automatically filtering for variability and constraints. We're identifying the best settings to reach those goals, and communicating to operators how they can make adjustments to optimize the process in real time. And ultimately, that solution is what turned into Process AI. So this is the Process AI interface here. On the right-hand side, you'll see 4 different quality metrics that are being received every second. So this is a wire and cable example. And these quality metrics, we have the predicted values as well as the test values that come in less frequently. So this kind of allows operators to see how the predictions are performing in real time, and allow them to get a tighter feedback loop on process adjustments and see if they're changing one variable, how does that impact their end quality. On the left, we see that scatter plot from before. That's showing the historical behavior. In this case, we are looking at line speed again and excess wall thickness. And what we're looking at with each of those dots is a stable segment based on historical periods of time to help them understand what settings can be used to make good product. And then in the background, we have another model selecting recommendations based on the current constraints of the process, the business objectives, expected behavior, and target outcomes. In this case, we are trying to increase speed and minimize material. So we're giving operators recommendations. We're allowing them to measure the impact of their changes. You can see on the bottom some of the value capture information, and really getting this type of information in front of a junior operator transfers that domain knowledge and gives them the ability to operate like a seasoned vet. So with one of our customers, large paper manufacturing customer that I worked with closely, we actually launched this product, gave it to the day shift, and it was awesome to see. But within a few days, we saw that the night shift was using it without being told or trained about it, just by having it up in their control room. They started looking at the recommendations and adopting them, and that was just a great quick success story. Usually change management is really tough, but a genuinely useful tool can be easy to adopt. Of course, we still have to work closely on change management. It doesn't always come that easy, but just awesome to see that getting the right information in front of operators can really help them with their job. So after data integrations, it takes us 48 hours to get a model spun up with reasonable accuracy. That's looking at 3 to 6 months of historical data. But like I mentioned, we're kind of turnkey when it matters, but consultative to actually deliver accuracy. So it'll take us about 4 weeks of just working back and forth with the domain experts. Those are your process engineers, your operators, to really understand the process better, tweak parameters, and improve accuracy. And our goal isn't to be perfectly correct every single time, but we do want to be directionally correct. So really help the operator understand, if they make this adjustment, is my quality going to go up? Is it going to go down? And by roughly how much? And this really allows the operator to operate the machine with more comfort. They're less concerned about quality failures. Also speeds up their understanding of the process. So getting these types of tools in front of operators really helps them get up to speed and execute on their day-to-day responsibilities. So let's look at some real-world results here. So this is a case study in wire and cable. This is the #1 electrical cable producer in North America, and they had a goal to increase production through higher line speeds. And using process AI, over the course of around 90 days and looking at 2 extrusion lines running many products, we were able to increase production rates by 20% and add 5.3 million additional feet in production over 90 days. And this was across 20 operators. So really allowing them to perform more similarly to one another and share information digitally through the use of AI recommendations and machine learning models. So you can see here, before process AI, new operators were historically underperforming the average production rates, and experienced operators performed much stronger, but generally didn't try to push beyond what they had been able to produce in the past for fear of causing issues and quality failures. And after process AI, we found that we're tightening that spread and moving it up. So new operators are now performing close to the level of experienced operators, and experienced operators are now also starting to push the boundaries as they have the confidence now that they could by being able to see what those quality outcomes would be. So this really results in them surpassing the previous production ceilings that they thought to be possible. And just looking at this case study a different way here, so you can see this dotted line here is the 6% improvement target, which we set. And we set that based on assessing the process variance. So if you could think back to that scatter plot that we looked at with speeds, we observed that that 75th percentile of speed was 12% higher than the historical average. And we asked ourselves, what if we could hit the 75th percentile 50% of the time? And that's what led to a 6% increase to production rates. So, this was an ambitious goal that we set, and we absolutely knocked it out of the park. There was, nearly 20% improvement over the 90 days. And, in this particular case, we were able to set a reasonable and attainable goal and exceed it through the use of AI and recommendations. Let's take a look at another industry. This is a chemical company, and we can see here 3 different clusters correlating to different products. Within each cluster, we're looking at the average production rate in 2023. That's that light blue bar. We're also looking at the target value for that product, which is the orange bar, and the average of their production rate while using process AI, which is the dark blue bar on the right. And we can see across the board, there were huge improvements in average run rate comparing the process AI usage to the baseline. But we can see, a couple interesting examples here. On the leftmost recommendation, we're really pushing the boundaries of how fast they thought they could run. The target was around 100, and here they are exceeding it by 2 to 3 times. And the other 2 examples, we're very far from achieving the target. We're around 50 to 60% to target, just because of losing experience. The tenure and domain knowledge that knows how to run certain products so quickly is being lost. And through the use of process AI, we're able to use recommendations and predictions to help them get above the target on average. So I have a quick video here of a customer case study. So here's some leaders from the Inks team about the qualitative impacts of using process AI and Odin to empower their frontline. Just go ahead.
It's user-friendly, color-coded system, so the operator, when he looks at the screen, he knows if it's red, I got a problem. If it's green, I'm good. If it's blue, I'm doing really good.
The operators are buying into it. The supervisors are buying into it. We have friendly competition between shifts based on production throughput.
So one of our first targets that we set was to benchmark OEE, or overall equipment efficiency, in the plant. We set a target to improve by 10% within 6 months, and they hit the target in about 4 months. And they've been able to maintain that target now for over a year.
Yeah, so that's a quick snippet from a video case study that we've published. The full video is available on our website at odin.io. So if you're interested to learn more, please check that out on our website.
It's user.
So to recap, AI is essential for the new workforce mix and enabling those junior operators to get up to speed quickly and performing like seasoned operators. To effectively use AI, you need a clean data source, and it's key to maintaining competitive advantages moving forward, both by not just improving efficiency, but also from a labor perspective. When you have young operators joining the workforce, they're eager for digital tools to help them do their job more efficiently, and it's easier to recruit and retain talent when they're empowered with the right tools to do their job. So yeah, thank you very much for joining and listening to our talk on making AI and data useful for the front line. I would like to wrap up the presentation portion and move into some Q&A.
Thank you so much, Ahmad. This is fascinating, groundbreaking kind of stuff. And clearly, over the next 5 to 10 years, it's going to become a main part of production manufacturing capabilities. So again, thank you for bringing out these various concepts for us to understand. In the wire and cable industry, are there any, I know you mentioned productivity, but any tangible results using artificial intelligence that Odin has been able to produce? It could be time or cost savings type of achievements.
Yeah, I would say our current case studies are focused on performance improvements, though we are currently actively in projects where the main objectives are reducing excess material usage. So that is one of the common objectives that we see in wire and cable and extrusion processes in general. To meet spec, a lot of times operators are putting extra material to ensure that they exceed the spec, and that can result in high material costs and waste. So that is another focus area of ours, but I do not believe we have published a case study for that. I would say some of our more savings-oriented case studies are in different industries. Yeah.
Good. What types of systems can Odin integrate with? I mean, obviously, different manufacturers have different operating systems. So, any thoughts on how your system works?
Yeah, that's a great question. So it's actually a large part of my role with our customers is to identify the systems and design the integration paths, understand where all of the source data lives that will be needed to meet the use cases and objectives. So we are ultimately platform agnostic. We integrate with any system that exists on a factory floor, provided it has, uses open communication protocols or it has already been centralized. So we connect through an IoT gateway, which converts OPC to MQTT. So any data source that can be available in an OPC server is accessible to Odin in real time. And then as far as the kind of offline information that we capture to help provide context and metadata to the process, that is all, we are also agnostic there, but I will say some of the most common tools we integrate with are MES systems, quality systems, ERP systems, to really understand, what's being made when, what were the quality outcomes of these production runs, and that really is the foundation for building our predictive models and process AI tools.
Very good. So artificial intelligence can be extremely powerful, but it can be extremely scary, particular for experienced folks in the industry. Interesting question. How have more experienced operators reacted or embraced these technologies? And don't you think that operators, especially the old school operators, will resist some of these software tools?
Yeah, that's a good question. I would say we get a mixed bag. I think upfront there's often that hesitancy that you mentioned, but once they start seeing the tool and the impacts that it has and understand that it's not there to replace them, it's just there to make their job easier, they actually start to love the tool. It allows them to focus more on value add activities, rather than having to sit by a junior operator and help them run the line. They can use the AI tool to take on that work, and generally, they are happy to see that there are tools out there that can kind of spread the information that has been in their brains for so long, and that hasn't been accessible to others. So yeah, I think we are potentially met with some hesitancy up front, but that is quickly converted, especially, I think, like you mentioned, the junior operators, they tend to be excited by it out of the gate, but some of the more experienced ones are, it takes some time to win them over, but they love to see the results.
Yeah, so many opportunities and benefits that this brings. Who actually creates and manages the data models? Is that something that Odin does, or do you engage with an individual within the manufacturer, for example?
So Odin, so we do take a relatively white glove deployment process. So we work with our customers to map their data sources into our data model. And then we'll also work on integrations as we look to add more sites and expand kind of the scope of our engagement. Then we start collaborating a little bit more closely and allow the customer to take on more ownership and driving that the data strategy and how to get all the necessary information to Odin. Generally that's aligned to enterprise data objectives. So we are working closely with our customers to ensure that the data is mapped correctly, both from a small proof of concept as well as we look to scale and deploy across many factories and lines.
Right. And in an environment where there's always a lot of change and new products are introduced on a quite regular basis, how does the process artificial intelligence work when there's not much historic data for a specific product, really just general fuzzy experience based on something similar? So how does this evolve for new product development and commercialization?
Yeah, that's a great question, and certainly a challenge that we run into in those high mix environments where you're maybe manufacturing to order or have many different SKUs introduced. We have several approaches to this. I would say the most common one is looking at attributes that allow us to compare that product with other product runs. So for example, in wire and cable, some of those attributes might be the compound that's going in, maybe the color or the diameter. So looking at those attributes allows us to kind of expand our historical data set and get more recommendations and build out the machine learning models. So rather than kind of looking at specific SKUs, we're able to look at a broader data set.
Good. Is the hardware requirement very high for the model to work? I mean, there's some experience that the hardware needed almost a half a terabyte of RAM in order to work. So can you give any comment on what's actually going to be required from a data standpoint?
Yeah. Yeah, so training and deploying models is certainly hardware and compute intensive. However, Odin is cloud-based, so all of that is really taken care of by us. We simply deploy the models in our cloud, and they're available to our users in their web browser. I will say there's scenarios where customers want that in their other systems as well. We do support kind of bi-directional integrations. So if you wanted the model to be generated in the cloud and then those values pulled into your on-premise historian, that is certainly something that's supported. But part of the value we provide is allowing our customers to not have to worry about the data infrastructure, beyond just sending us the information. So really simplifying that machine learning stack and enabling models to be delivered in a relatively turnkey manner.
Good. A practical question about starting a project and when you can actually make use of it. But when you start a project with a new customer, what level of data collection is required prior to getting it going, right? Is a complete data collection system in place required, or can you kind of evolve into it?
Yeah, another great question. I think we find that that's generally one of the concerns is, I don't have all of my machine data centralized. I will say that we generally want there to be at least an OT network in place with kind of core assets connected. And the way we approach these scenarios is taking a focus on a sort of lighthouse facility that already has that connectivity in place, the data centralization in place, to allow us to go in and deploy quickly. By being able to kind of go in and show results and the value that you can get out of having your information connected, that way we can then justify the investment in other sites to build out that infrastructure and networking and data connectivity. We know those are kind of daunting projects that often involve many parties, your internal maintenance, your internal controls, your engineers, systems integrators to really get everything all in one place. And we want to make sure that we can show we're not just gathering data for data's sake. We are putting data to work and making it really useful for the front line, showing the value and justifying that investment.
Very good. Okay. Does Odin and your process work well connecting to existing databases, or is that something that you would have to create?
Yeah, another good question. So like I said, we are agnostic, but we do require a real-time data stream today, meaning that we want to be connected to something like an OPC server or SCADA or DCS to understand the real-time conditions. But given that we are a machine learning and an AI product, historical data is gold to us. And without building out a historical data set, we're kind of waiting around for 6 months or so until we have the right amount of information to proceed. So what we do to get around that is work with our customers to extract the data out of their existing systems and pull it into Odin. So that can be, it's a little bit of a process, but it's something that, again, we handle in a white glove manner, really pulling that information out, mapping it to our data model and format, and then ingesting it into our cloud suite, which then makes it available for all of our tools.
Right. A few more questions, and then we'll wrap up. Does Odin support the hardware connectivity? Do you provide gateways for typical cable machinery? I know you mentioned cloud-based, but
So we do not. We actually used to, but have since gotten away from hardware. But we do support open protocols, meaning that any sort of hardware gateway that's commercially available would work with Odin. So really looking to kind of expose the tags in the control system to any system. So you could, install a gateway on the machines. You could install a server on site running something like Kepware that say has drivers for all of these, different PLC types, Kepware ignition, and use those types of solutions to kind of solve the first level connectivity problem. And then we layer in our IoT gateway to then transfer all that information in a real-time stream to Odin.
Great. Yeah, one last question. Is the model that's generated, is it separate for each product, or is the system able to identify with its artificial intelligence the product based on data from the MES system? I mean, how overlapping is the data when you switch from one product to another on a particular line?
So usually we get that product information from an existing system, like an MES or ERP. That is often a data enrichment problem to properly align that with the changeovers, as we talked about earlier. But those models can actually be generated in both ways. We have the capability to do product-specific models as well as cross-product models. We tend to favor cross-product models because they explain the overall process better. But for specific processes where that doesn't make sense, we can deploy product-specific models.
Well, that was fantastic. Very, very interesting, and it's an important topic that we all should understand. One of your polling questions was, how are you going to embrace and enact some AI systems in the future? And the answer is, of course, right? And it's something that we're all going to have to figure out over time. So, again, I want to thank Ahmad for presenting this topic today. Also, if you have additional questions, please feel free to reach out to Ahmad. You see his contact points here, and I'm sure you'll get some great responses and more in-depth responses from the Odin Technologies team. Each one of these webinar series events are recorded, and they will be archived on the IWCS website. Normally takes a week or so just to get it up and running. We have a lot of different webinars there. You can browse and see what topics we have covered over the last 9 years. We've been presenting these webinars. So our next scheduled technical paper presentation webinar will actually be this Friday, November 15th at 10:30 a.m. Eastern USA time. So each of you will be receiving an announcement for these events. So please feel free to share those announcements with your colleagues so that they can join and register as well. So again, I want to thank everyone and remind you that our call for papers is about to be launched for 2025. And our event will be in Pittsburgh, Pennsylvania, USA at the end of October. So be on the lookout for information that you'll receive both in email, but also posted on our website. Very simple process, but as you evolve your own technologies, please feel free and consider presenting them to our global audience. So again, we look forward to having you participate in our future webinar events and, of course, in Pittsburgh. So again, thank you to Odin Technologies. What a great presentation, and have a great rest of your day.
Thanks for having us.
Thank you, Ahmed.
Thank you.